Hello, everyone. Thanks so much for joining us today. We're going to give it about another 60 seconds before we get started. We are going to get started in about 30 seconds. So thanks everyone for joining us. And yep, we're just going to get started in just a few more seconds to let a few more people join. Okay, well, thank you everyone for joining us for today's webinar on the complexity matrix. My name is Michal Wachstock, and I'm Director of Online Marketing here at Sisense, and I'm thrilled to have you all join our webinar. I'm going to be introducing our speaker, Jeremy Sokolic, who's our VP of Product here at Sisense. A few housekeeping notes before we get started. First, if you have any questions throughout the webinar, please feel free to ask them through the chat box at the top of the screen. I'm probably going to hold those until the end of the webinar and let Jeremy answer them then, but as soon as the questions come to you, you can feel free to send those over. Additionally, you can, at the end of the webinar, we're going to ask you to submit feedback on how you thought this webinar went, and we'd love to get your feedback. There is going to be a recording of this webinar, an on-demand version available immediately after the webinar is completed through the same link that you registered through, so you can have access to that at any point. And we are going to be sending a white paper about the same topic to everyone who is on the webinar who's registered. So, check your inboxes for those once the webinar is over. And with that, I would like to introduce Jeremy, who's going to continue on with the presentation.
Good morning, everyone. Nice to speak to you today. Thanks for joining us. My name is Jeremy Sokolic. I'm the VP of Product at Sisense, and really appreciate your time today. Just by way of background, spent a number of years as a consultant with McKinsey & Company and have been since then in various software companies in the B2B space, two of them very focused on business analytics data. CashEdge Inc. was a payments company that did quite a bit of risk analytics, and LivePerson is a big data analytics company that uses data to optimize web chat and web customer experience. Very interested in the topic that you all have signed up for today, and hope you'll find it helpful. Just to give you a quick overview on who Sisense is, we are headquartered in New York City. We have approximately 700 customers across 50 countries, spanning the full range from SMBs to Fortune 100 companies. Have a lot of experience working with companies that are looking to implement business analytics solutions. In terms of our recognition in the industry, it's been pretty significant, a number of awards from various industry groups, analysts, media companies, and so really appreciate that feedback in the market. And a number of good articles and coverage from the press, really documenting the disruption and the changes we're bringing to the business analytics market. And so happy to tell you more about Sisense, if and when it's interesting. So many of you, I'm sure, signed up today because of the real explosion in data that you're seeing around you. Just a few facts here, some data from IDC. They expect by 2020 that the world will see 40 exabytes of data, a huge number, growing compound annually at 48%. And I'm sure you're experiencing this both in your business. And not only is it kind of a push, but it's also a pull. There's growing demand. The whole consumerization of data and analytics, BI really moving downstream from large organizations to smaller organizations, And when Aberdeen surveyed managers of a full range of companies, what they found is that people said the decision window for making decisions is shrinking. 64% of managers said that. And so the need for getting data quickly to be able to use it for business decisions, quite important. And I'm sure that's a main reason why many of you are here today. When you think about data and data complexity, there are really two main drivers that we see in the marketplace. One is how big your data is. And you'll see here a quote, 79% of people either say they use big data or plan to use it in the next year. And that's just a self-described understanding about how data is important to their business. And really, big data can be a pretty wide-ranging topic. And what's big for one person may not be so big for the next, but it is relative. And that's why this stat is so interesting, because no matter where people are in the spectrum, 80% say that they expect the need to handle bigger and bigger data over time. The other interesting thing to think about when you think about data complexity is the number of data sources that someone is using in their business. And here you see a pie chart on the right from Ventana Research. And what that shows is that 70% of people who actually knew how many data sources they needed to use in their business actually use more than 6. So that's a pretty staggering number in terms of how they need to optimize performance and integrate multiple data sources across their whole business experience. And so those are two key drivers in what we see really creating confusion and complication around the whole world of business analytics and what people should be doing with data. And to solve that, we've developed this framework that we call the data complexity matrix. And really there are two angles to this. So one is data size, is your data small or large? And the other is the number of data sources. Do you have few data sources? Do you have many data sources? And here, when I mean data sources, that can mean multiple kinds of data sources. So you're trying to integrate data from an accounting system, an ERP system, maybe from Salesforce, maybe it's web analytics, Google Analytics. You may be trying to bring in ad hoc analysis from a spreadsheet that you downloaded from somewhere, or some analysis you developed on your own. And that can go all the way to you're bringing in a SQL database that's got 10, 15, 20 different tables that you need to analyze. So it's not just the number of sources, but it's also the number of tables or logical data structures within those sources. And when you look at that 2x2 matrix, you really can start to kind of categorize data into different categories. And you'll see here we've categorized it into simple, big, diversified, and complex based on how someone fits in this matrix. And maybe to make it a little more approachable and understandable, you can also think about characters that might fit the bill here. And so if you think about simple data, you might come to Linus, right? From Peanuts, Charlie Brown. Very simple, very straightforward guy, tells it like it is, and he's characteristic of simple data. Big data might be someone like Charlie Brown. He thinks he's a larger-than-life character, but really not very complicated. On the diversified side, you may think about one of our favorite Peanut characters, Pigpen, right? He's got lots of complicated stuff going on, things all over the place, falling in and out of his pockets, lots of different things impacting him, and that's why he's diversified data. And lastly, we've got Schroeder, really the most complex of the Peanuts characters. Never quite sure what's going on in his mind. Doesn't really talk that much, but he's got a lot of output and a lot of things going on with him. And when he says something, it's actually pretty interesting. And so just a nice, easy way to think about the various data sizes and data sources and how they match up to characters you might be able to relate to. And what I'm going to do now is go through each of these quadrants and talk a little bit about the characteristics of each quadrant, what some of the challenges are, and what are some considerations you should have, depending on where you fit into this matrix. So simple data, our friend Linus with his security blanket. It's typically smaller data size, and you may have a question, what exactly does that mean? That could be anywhere in the millions of rows of data. it's typically a limited number of data sources or tables. Maybe it's 2, maybe it's 3 tables that you're trying to bring together, or 2 or 3 different data sources that you're trying to bring together. And the key thing about small data with limited number of sources is it's relatively easy to prepare for analysis. And in business analytics, the data preparation is actually a very key part of this, and it's a theme you'll see permeating throughout the discussion on each of the quadrants. And when I say easy to prepare for analysis, there's no really need to optimize the data model, no need for significant data massaging. If you've got 2 or 3 tables, it's pretty easy to figure out kind of how they fit together and what are the various opportunities to analyze data across those sources. Small data also gives you an option to directly query a live database. So if you recall and think about the start of the whole business intelligence and business analytics markets, they started with specialized software that basically was optimized for doing analytic queries without impacting the transactional processing database that an application was using. And when data is small, you can actually query a live database without being too concerned about that kind of impact on the transactional system. And so if you fit into that category and you're thinking the data you need to analyze matches up with our friend Linus there, there are some things to consider. Is your data always going to be small? How will it grow? How will it grow as your business grows? Will you need to bring in additional data sources over time? So as you think about new marketing channels, new business activities, are there other kinds of data that you'll need to invest in? And as the size and number of data sources and the size of your data grows, you have to think about how will my business analytics solution scale, and how can I keep pace with it? And there may be lots of folks that say, you know what, I'm always going to be simple data, and then there might be specific tools that are appropriate for you. And so when I think about with simple data, what works, what doesn't work, it's really ideal for some of the self-service data visualization tools that are out in the market today. Very straightforward, easy user experience. If your data is small, simple, not many sources, relatively easy to prepare the data for those kinds of tools. However, that challenge does get magnified in the context of a real-time connection to a transactional database. And so if your data starts out small and you have a real-time connection, it can be great. As it grows, more users, more sophisticated queries, performance impact can start to be significant. And you also have to think, as your data grows, will it impact my transactional system as well? And just as a point of reminder, and I'm sure many of you understand this, the #1 inhibitor to user adoption for business analytics solutions is poor performance. If someone gets to a screen and the page is not loading, a query takes forever, they can quickly get frustrated with the solution. That said, simple, small data, there's lots of good tools out there that can do the job and actually really enhance what you're doing, because they take you from a world of columns and numbers and spreadsheets to a visual world that people are able to interact with much more intuitively. So our next data category is big data. Remember our friend Charlie Brown. So what does big data mean? Typically that's larger data sets. A limited number of data sources, so maybe less than 3, something in the, tens of millions to hundreds of millions and beyond in terms of rows of data. And from that standpoint, you need to start to think about special preparation from typically technical resources in order to query that large data with reasonable performance. You may need to do indices. You may need to do aggregation tables. You may need to think about clusters of machines. So you may need to think about some of that data remodeling that I mentioned before, where you actually have to optimize data into a certain way so it can be queried effectively. And all of those are important considerations when you've got very large data sets. And so what are some of the things you need to think about there? #1, a real investment of time and resources from an IT team, from a consulting organization to initially build a big data solution. But even more importantly, typically you need that ongoing resource to be able to respond to new business questions. So because the data size is so significant, when an analyst wants to add something new or change the way they're looking at that data, sometimes there needs to be work done to actually prepare the data for analysis. Again, going back to aggregation tables and those sorts of things. There's also quite a bit of effort in applying structured or in applying structure to unstructured data sources. So a lot of people, when they think about big data, think about unstructured text data, video files, things like that. They may think about MongoDB as a database or Hadoop that are used to store those kinds of data sets. And there is quite a bit of effort that needs to go into being able to structure those kinds of unstructured data sources and make them friendly for business user analysis. The final point to consider when you're thinking about big data and all the work that goes into preparing it for analysis is there is a risk of losing some of the granularity of that. And so when you think about your analysis and what you're trying to accomplish and what level of data granularity you need, that's important. Because think about kind of what I said earlier. When a resource is preparing big data for analysis, it usually involves some kind of summarization, aggregation of that data. And when you do that, you can lose the granularity that may be relevant or important as you start to analyze business questions. So those are some of the issues to consider in big data. And when you think about what works, what doesn't work, that data preparation step definitely requires investment of time and resources from an IT team before any analytic output can be generated. So if you're thinking about business analytics for big data, you know that you've got a little bit of a process ahead of you in terms of just getting ready to do the analysis. There may be some specialized tools that you need to think about, a data warehouse appliance. Some of the vendors in that space are Vertica and Netezza. There are some in-memory solutions that often are touted for working well with big data, but they have inherent limitations in terms of the size of the data and the number of concurrent users that can access the data at any given time. The more users you have, the bigger hit on an in-memory solution because those users consume memory in and of themselves just as users of the data. One thing to think about here is that the additional moving parts that come from those data warehousing tools has both direct and indirect costs. So obviously, if you need to buy a data warehouse tool because of the size of your data, you've got a licensing fee for that. But there are indirect costs as well. You need to start to kind of build a business analytics assembly line, piecing together your visualization tool, your database, your data warehouse, and making sure all those tools fit together. And as they are upgraded and new releases happen, it becomes an ongoing maintenance effort. I talked a little bit before about the risk of missing insights without full data granularity, and that is something to think about too and to consider in developing a program for big data. And lastly, you have these iterative cycles with your IT or consulting organization, which typically extend the time to insight. So with big data, especially when it's aggregated and summarized, there's a lot of prep work that needs to happen. And analysts will start to ask some questions. Okay, I want to look at my data by country or by region. And then, I want to look at it by gender or by age. And those are simple examples, but in essence, the point is that the data needs to be prepared based on how an analyst wants to slice and look at it. And that creates some iterative cycles with IT organizations around what are the requirements, how do we prepare the data, et cetera. And so those are some of the challenges, what worked and what doesn't work with big data. Our third quadrant, diversified data, really typically looks at smaller data sets, but data sets that are derived from multiple data sources and multiple tables. And I mentioned that earlier. It's an important component. You may have only one database that you need to analyze, but it may be a very complex database with lots of tables and very complicated logical relationships between those tables. And so for diversified data, you typically require special attention in the ETL steps, so the extract, transform, and load steps. And that's all of the steps that are done to actually kind of organize the data, figure out the right structure, make sure that those various data sources have the right logical identifiers so that you can link them together appropriately. And when you do your analysis, it's actually accurate, that you're not missing somehow subsets of data because of the way the logical relationships have been structured. And that's a very key point in diversified data. So some of the things to consider there, you may need the skills, again, of a DBA, either an employee or a consultant, to remodel data, to create new data schemas, maybe to just create views of the data. So if you've got lots of different sources and you're trying to do an analysis on them, depending on the tool you're using, you may have to create a special kind of flattened view of the data, which is just a table that pulls data from various sources, links it up appropriately, and there you make sure, again, that you're not missing something or you haven't duplicated data in some inconsistent way. When you have diversified data, one of the things to think about is the frequency with which you expect to add new data sources. Because every time you add a new data source, again, you've got to kind of revisit this data model issue and how the data is logically structured and organized. And so again, that becomes an area of ongoing maintenance and concern. And so for diversified data, when we think about what works well and what doesn't, as I mentioned, an ETL tool almost typically required for this kind of data. It's an investment of time and resource, again, before any analytic output can be generated. So if you've got diversified data and you're thinking about launching a business analytics program or trying to upgrade what you have, definitely need to think about that from a timeline standpoint. Informatica is an example of a tool here in this space that helps in that specialized ETL and data preparation. Part of what ends up happening here is you have longer implementation cycles to overcome this issue with multiple data sources and modeling discrepancies, and you tend to have to go through a number of iterative processes to get that right. And like we talked about before with big data, there is this additional moving part now. If you think about your assembly line, you've just added something on the front to say, okay, I need a special tool to do my ETL. And again, that's a license, a maintenance, et cetera. And so that does both add direct and indirect costs to the process here. So our last quadrant, our friend Schroeder, is really complex data. And complex data is combining kind of the challenges of both diversified data and big data. So it's typically larger data sets, again, tens to hundreds of millions of rows, multiple disparate data sources, lots of tables within those sources. And you have the same challenges that we talked about earlier, the data modeling challenges we talked about in diversified data and the data size challenges we talked about in big data, because complex is where both of them really meet. And so, same kinds of things to consider, the need for specialized resources really to handle both the modeling and the data size. As the data gets more complex, the challenges really get amplified. Each time a change is needed, whether it's to a new data source, to a new kind of analytic, there tend to be these iterative paths that you need to go through. And so what works well, what doesn't work so well in complex data, typically requires a significant investment of time and resource from an IT team, from a consulting team, before you can really get to your output. It may require those specialized ETL or data warehousing tools. And typically this becomes a lengthy cross-departmental project, lots of people involved, lots of effort around it. And that's been the whole history of business analytics as it's developed in the 90s and 2000s. Of course, higher total cost of ownership here. If you've had a bunch of multiple tools, there'll be license fees, there'll be overhead to maintain those tools. And oftentimes those tools comes with the need for specialized consultants or integration skills to make them do what they need to do and then to make them work together. And ultimately what happens in complex data is the agility for the business analyst is typically diminished. There's a longer time to insight. There's more time interval between kind of going from one insight to the next. And if you think about that in the complex data world, if an analyst goes through a process to do some analysis, get to some insight, and then they need to take it to the next level, or they need to kind of swerve and change directions, right? That insight, generates an aha moment, which is, okay, you know what, I better look at this kind of data or that kind of data. And complex data, that starts the whole kind of process again around, all right, where do we get the data? How do we model it? How do we make it fit into our data framework, et cetera? And so that becomes a relatively lengthy process. And so now that you understand the various the various quadrants in the data complexity matrix, and you're thinking about, how do I, first of all, identify myself? Am I Linus or Charlie Brown? Am I Schroeder or am I Pigpen? And, am I that person today? And where will I be tomorrow? Those are important things to consider. Each of those quadrants has its own set of unique aspects and challenges that we discussed. Not surprisingly, there are specific tools that meet each of the needs of these various challenges in these quadrants. One thing you just definitely need to think about is, where am I today? Where will I grow? It is a big investment to develop a business analytics program, and you want to make sure it can grow with you over time for sure. So just another way to think about the data analytics ecosystem, again, thinking about data complexity here on the x-axis, so big disparate data sets, the part of our matrix that we call, big data or complex data, and then also the ease and agility of use. And if you think about kind of the history of how these tools have developed, there were lots of legacy tools, names like MicroStrategy, Cosmos, Business Objects. They were really designed to handle very complex big data, but not the easiest to use. Then over time, people realized that ease and agility of use were very important, and you could develop a great system, but if no one used it, it didn't really deliver the value you were hoping for. And lots of modern self-service tools developed around ease and agility of use. And what we've seen in the market is those tools were great on the smaller, simpler data sets. But when you looked at big, complex, disparate data sets and still wanted something easy to use, there weren't really players in the market. And that's really where SciSense fits in and where we position ourselves. And that's the complex data quadrant of the data complexity matrix that SciSense is trying to address. And so really our mission, just as a company, is simplifying business analytics for complex data. And what I mean by that is we're doing projects in days versus months, no specialized IT, a complete single platform that does your ETL, database, visualization, analytics, all in one tool, so you kind of can move away from this business analytics assembly line of multiple tools. And when we say complex, really what we described before, many disparate data sources, lots of big data sets. And that's really our mission as a business analytics company. And so just quickly on our technology, we have something called in-chip technology that really solves problems for big data with unparalleled data processing speed. So we're happy to go into this in more detail at the right time, but that speed of processing really helps eliminate much of the data preparation work that I talked about, eliminating the need for a number of those specialized data warehousing kinds of tools. And that's really kind of the first punch in our arsenal. The second is our
Jeremy, are you there? I can't hear you. I'm just making sure if this is just me not being able to. Okay, you're back.
Yep,
Great, thanks.
I apologize. Sorry, where did I leave off?
You are already on the next slide.
Okay, sorry, I apologize. Something happened here on my side. Great. So just quickly, the 1-2 punch I talked about. So SciSense's in-chip technology really solves problems for big data, unparalleled speed, really eliminating much of the data preparation and the need for specialized data warehouse tools. That's our first punch in the arsenal here in terms of addressing complex data. Our second punch is what we call our single stack technology, and that really solves problems for diversified data. So we unify the whole business analytics process into a single piece of software that does ETL, database, visualization, analytics, all in one package. So you can move away from this business analytics assembly line that typically makes you patchwork together multiple kinds of tools. And like I said, that's the second punch in our arsenal. And then the third punch, really, when you combine our in-chip technology and our single stack technology, it gives you the 1-2 punch for faster processing of larger data sets, very simple mashing up of multiple data sources. And in true Peanuts fashion, that's where you get to Snoopy with his gloves above his head, really solving the problems. And that's really what we are in the business to do. Very happy to spend some time talking with you. We've got 700 clients, as I mentioned before, marquee names, small businesses, really across all verticals that use our platform to solve these big data, diversified data, and complex data analytics problems. And most importantly, we'll prove it to you. We're the only vendor out there that, because of our technology, can do a live proof of concept on real data in a 90-minute web session. And so very easy to test this out and see how it works. And we've had a lot of success in the market in that regard. And with that, I'd say we're here. We're happy to help. We're happy to be a resource as you think about which of the quadrants you fit in and what your specific needs are. And where it's appropriate, certainly we will direct you in the right direction in terms of tools and what you can get in the market. So with that, I wanted to say thank you. I know we have a number of questions, but really appreciate everyone's time today.
Great. Thank you so much, Jeremy. Yeah, we actually have a few questions that are sort of similar, so let me sort of group them together. There were a few questions about, where's the line between, just, I guess, regular data and when data gets complex? How many sources and how big does the data need to be? And then I guess as a follow-up question is, a vendor who starts off as, a small data company, how does he then deal with the fact of he's now a big data company?
Right, and really, it's interesting. The questions around data size, particularly, are all relative. What one person kind of thinks is a huge data size to another person is really not big at all, and that has to do with the kind of spectrum of tools that are out there. And there are tools all across the whole spectrum of data size. Typically, what we see in our customers is when you start to get to tens of millions of rows of data, we would start to classify you as bigger data, not simple data. And then goes up from there. Our tools are in a sweet spot of the tens of millions to a few billions rows of data. And then there's a whole other set of technology and data warehouse tools when you're multiple billions of data to terabytes and petabytes of data. And there you really do need specialized tools. So I think the key thing is to consider where you are today, where your foreseeable growth is. One thing that's not changing, as we saw on the slides early on, is the growth in data. And so even companies today that think they're relatively small and may fit into that simple quadrant, very quickly when they start to see the power of the analytics and what they can do, they typically yearn for more. So we would advise people to always shoot a little bit beyond where you think you're going to be. Clearly there's a cost benefit and trade-off analysis everyone has to make in terms of how much they have to spend on a project. But like anything in business, where you see success, you'll start to see more and more demand, and that's very typically what we see with our customers.
Great. What about any best practices in terms of structuring really big data? I know that we have at SciSense.com in our documentation and our community, we have lots of tips and tricks, and both from our internal support team and also from our own customers and evaluators. But I'm wondering if you have any 2 or 3 or best practices for how to structure that really big data.
Yeah, and so the actual structuring and modeling of that big data is really a capability that needs some real expertise and some skills. What we see in our tools and the way we've built our tools is we've tried to diminish that by making everything very visual and drag and drop. But there are lots of things to consider, and as your data grows, you may certainly need to think about some of the techniques I talked about, aggregating data, creating summarization tables, really thinking hard about what is the data that you need to analyze. I mean, I'll give you one example from one of our customers. Because SciSense is so easy to use and they really can support pretty large amounts of data, they literally took a copy of their whole transaction database and pulled it into Sisense, and it created a data store that was 175 gigabytes, and it grew over time to 300 or 400 gigabytes. And in that kind of scenario, you really need to kind of go back and look, really, do I need all this data? What is the data that I'm trying to look at and analyze? And there are ways to optimize that over time as it grows.
Great, thanks. Another question about ETL. Are the transformations and business rules visible to end users?
Sure. The ETL process within Sisense is very straightforward. We have a part of our tool, it's called the Elastic Cube Manager. That's our data store. Within that, you can actually perform the ETL right within the tables that you're pulling in. So we have a bunch of predefined functions, capabilities, things like concatenation, things like date time transformations. All of those work very simply like Excel functions. You plug them into a column of the table. You reference the column that you want to transform, and it gives you a new column right there in the table. We also provide full native SQL right in that Elastic Cube Manager, so you can do any kind of SQL statement that you need to do. Now, in the setup of the data store, that typically does start to involve some technical resources, and it can be very simple and straightforward. But as you start to get to some of the more sophisticated things, you may need some additional resource there. But it's not a proprietary scripting language. It is basic SQL and very easy to pick up.
Great. I'm also going to sort of take a few of these questions and bunch them together because they're several, and I don't want to take too much time answering them. But can you talk a little bit about the kinds of data sources that Sisense can support, both proprietary formats and sort of off-the-shelf formats, standard formats? Right.
So Sisense provides connectors to a full range of data sources. Including all of the major databases. We provide connectors to many of the web applications, so things like Salesforce, in addition to some of the big data stores, Redshift, and some of the unstructured ones I mentioned before, like MongoDB. So Sisense really operates in two ways. For the data sources that are most prevalent, we'll build actually a native connector ourselves that is optimized for that data source. And then we also have a number of generic kinds of connectors using the ODBC format to actually pull data in any, from any data source that supports that ODBC framework.
Great. How about where do you see most BI projects failing?
So it's interesting. It's a good question. As I mentioned earlier, the key kind of point of failure for BI projects is around performance, and that's really why thinking about the size of your data and the complexity of your data is very important. If you go through a process and your query response time is poor, you're not going to get users to use the system. If it's not an intuitive user interface, again, it won't be easy for people to learn. And that's where the agility of a tool like Sisense really pays off, because there's nothing more frustrating for a data analyst than getting to a point in an analysis and kind of hitting a roadblock because the data is not formatted or structured in the right way. With a tool like Sisense, you can quickly kind of pull in new data if you need it. You can drill all the way down to the granular data in your data source right from a web dashboard without having to go back to an IT organization and ask them to do something different. So those are some of the important steps there. But by far the largest part of typical IT projects is in the data preparation. And so 80–90% of the work is up front, using the legacy tools that were out there. And that's really where Sisense has tried to make a big dent in the feasibility of successfully launching business analytics tools, because we've eliminated so much of the data prep. Not all of it, because clearly you can't do that, right? But quite a bit in terms of how our tool works. We've tried to address that big problem in a significant way.
Great. I'd also, in response to some of the questions, I'd like to mention that on our Bright Talk channel, the SciSense Bright Talk channel, you'll find a whole bunch of other recorded webinars specifically about data modeling, about building an agile data warehouse without IT. Some of the topics that you've touched here, there are supporting webinars that I think could really add some more depth to some of the topics that you discussed. So if anyone is interested in that, the SciSense Bright Talk channel has those recorded webinars available on demand. I think we have time for one more question here. Where are you seeing the most effort spent in BI projects?
Yeah, and as I mentioned before, I think it is in the data preparation. And that's been historically one of the bigger issues with data analytics projects, especially in taking them downstream to smaller companies that don't have the same level of IT resources. And so, you can still expect to spend a good amount of your time in that process, but, really reducing that and minimizing the complexity, not only of the preparation, but the ongoing maintenance of data and data sources and ETL is one of the key differentiators of SciSense.
Great. I want to get another question in if I could. How does SciSense deal with data governance and information security?
Sure. So it's a very, very important part of what we do. About a third of our business is actually OEM business, where someone is embedding our application into their own. And obviously, their data security and governance is critical. You only want to let people see the data they're entitled to see. So SciSense provides single sign-on using Active Directory. We can also do proprietary single sign-ons. In that single sign-on, you can pass user groups, user roles at the individual user level or at a group level. And the data available in SciSense is all governed by that roles-based access, down to the actual row level and all of the underlying tables. So very, very sophisticated data governance in terms of who can see what and who's entitled to see what, both at the data level and also what we call the dashboard or widget level, which is our visualization layer. So a dashboard is made up of a number of different analyses we call widgets. So each widget, each dashboard, each row in every table can be security controlled.
Great. So I think with that, I will thank everyone for joining. I would like to mention that SciSense does offer a free trial on our website at scisense.com, and everyone is welcome to go and give this a try. As Jeremy mentioned, you can, with just a few clicks, you can really bring in your own data sources and start seeing visualizations right away. So if there are no other words or questions, I will thank everyone. And as I said, the recorded webinar will be available within a few minutes of ending this presentation. Thanks everyone for joining us.